squared. The average kinetic energy of a molecule therefore is given by K average is 1/2 mv bar squared. This is the average kinetic energy of a molecule, where v bar is its average velocity. Now, I'm going to replace this v bar squared. Look at this. This v bar squared is replaced by 3vx squared, because we said vx squared is 1/3 of v bar squared. V bar squared therefore is 3 times Vx squared. So the average kinetic energy of a molecule is 3/2. Well, let me write that step for you. I omitted a step there. What that means is it will be 1/2 times m times 3 v squared. That will be, see, this 3 I'm going to write as 3/2 mvx squared. Is it alright? 3/2, this is the 3/2 mvx squared. But what does mvx squared equal to? If you remember, if you simply take away these 1/2s, this mvx squared equal to kt. So I can therefore say this is equal to 3/2 mvx squared, which is 3/2 kt. Now look at that. The average kinetic energy of a molecule is 3/2 kt. I want you to sort of assimilate that information. Now, this 3/2 kt is actually made up of 1/2 kt along the x direction, 1/2 kt along the y direction, and 1/2 kt along the z direction. Now, we assume that a molecule is free to move in the x, y, and z directions. And we say a molecule has 3 degrees of freedom. What is the meaning of a degree of freedom? The freedom of a molecule to move in a direction. It can move in the x direction, y direction, and z direction. So we assign 3 degrees of freedom. The energy of a molecule in the x direction we calculated as 1/2 kt. The energy of the molecule in the y direction is also 1/2 kt. The energy in the z direction is also 1/2 kt. So the total energy of a molecule, the average kinetic energy of a molecule, is 3 times 1/2 kt, 3/2 kt. So if I ask you, what is the kinetic energy of a molecule per degree of freedom? What would be the answer? Per degree of freedom. This is the total kinetic energy for 3 degrees of freedom. Therefore, the energy of a molecule per degree of freedom is 1/2 kt. Don't forget that. I will ask you that about 2 classes from now. The energy of a molecule per degree of freedom is 1/2 kt, where K is Boltzmann constant and T is the absolute temperature. The total translational kinetic energy of n moles of a gas containing n molecules. This is the total energy, translational kinetic energy of 1 molecule. So what is the total kinetic energy of n molecules? That will be, the total kinetic energy is 3/2 nkt. That will be 3/2 nRT. Did you understand how nk become nr? I hope you understand that. Let me show that to you. Now, take this n times k. The n, the total number of molecules, can be written as Na times n and that is multiplied by K. I hope you understand that. The total number of molecules is the number of molecules per mole, that is Na, that is Avogadro's number, multiplied by the number of moles. This will be your N. And you know, Na times K, what do you call that? Na times K is called your R. So big N times K equal to small n, the number of moles, times Na times K is R. Okay, let's go on. So 3/2 NKT is the total translational kinetic energy of N molecules, which is the same as 3/2 nRT. Alright? If M total is the mass of N molecules, M total simply is a notation we use for the total mass of N molecules. What is the mass of one molecule we assumed earlier? The mass of one molecule we assumed as lowercase m. Therefore, what is the mass of N molecules? That will be N times m. So, if M total is the mass of N molecules, then 1/2 M total V bar squared. Remember here, this K stands for the total kinetic energy of N molecules. And this N molecules has this mass, the total mass of N molecules. And you know that kinetic energy is 1/2 mv squared. M is the total mass of these N molecules. V bar is the average velocity of each of those molecules. Therefore, 1/2 mv bar squared is a measure of the total kinetic energy of all those molecules. And that should be equal to 3/2 nRT. Now, look at this. I consider this as a beautiful equation. It is going to lead us to the average velocity of a molecule. We can now measure the average velocity of a molecule. Isn't that beautiful? Yes. We get V bar squared equal to 3 nRT over M total, or that will be 3 RT over, what I did is, this N, I divided this by that N. Do you understand that little manipulation? You see, M total divided by N. This N actually belongs to the numerator. But if I write it like this, it has a significance. What is the significance? M total divided by N. Tell me, what does that represent? The total mass of the gas divided by the number of moles of that gas is the molar mass of the gas, the mass of 1 mole. So this will be 3 RT divided by M, where M is the molar mass. V bar squared equal to 3 RT over M, where M is the molar mass. What is V bar therefore? V bar therefore is square root of 3 RT over M. Isn't that beautiful? We can calculate the mean velocity of a molecule. Now V bar is called the root mean square velocity of the molecule. So the root mean square velocity, you simply understand it as the average velocity of a molecule, is square root of 3 RT over M. And we also very often call it VRMS. RMS stands for root mean square velocity. So VRMS equal to square root of 3 RT divided by M, where R is the universal gas constant, T is the Kelvin temperature, M is the molar mass. You can see R is a constant, the molar mass of a substance is a constant, Therefore, what does the velocity depend on? On the temperature. That means temperature, do you remember in the earlier part of this lesson we said temperature is proportional to the average kinetic energy of the molecules. You see that? And that's what this relation tells you. 3 over nr is a constant. So the kinetic energy is proportional to the temperature. You can see our assumptions are proving to be so good. Alright, now we are ready to use this to solve a couple of problems. Problems using the results